Two-dimensional mechanics. We're going to start with how do we add vectors in 2 dimensions. And we're going to show a couple different ways to do it. One is with a ruler and a protractor. Then the other is using right-angle trigonometry. Then we'll talk about how we can add vectors, resolve them into components, and then 3 different problem types of things here: projectile motion, the inclined plane, and equilibrium. And finally, we'll work out some problems in great detail. Adding vectors in 2 dimensions. Earlier in the course, we learned how to add vectors along a single axis. The example that was used was for adding 2 displacements, and we were working on the x-axis here. And you can see we have north, east, south, and then west. We started with the first vector, in red over here. You begin at the origin, and we call this part the tail of the vector, and then you extend it out for its magnitude, and this is the tip, the arrowhead. Next, you draw the second vector, and that's this green one here, and you can see it's in the opposite direction, so that had a negative value. You put the tail of the second vector here onto the tip of the first vector, and then you draw it out, so here now is the tip of the second vector. We only have 2 vectors that we're adding here, the red one and the green one. And to find the resultant, which is the sum of the 2 vectors, and we call that the resultant, you start back at the origin, which was the tail of the first vector, and you draw it out to the tip, the arrowhead of the final vector. And this purple vector here is the sum of the red and the green vectors. Because we're dealing with vectors, in addition to the magnitude, the direction matters. So for this case, our red vector here was 5 units to the east. The green one was 2 units to the west. Our resultant, you can measure it off, is 1, 2, 3. It's 3 units, and it's pointing to the right or the east. So the answer is 3 units to the east. Another way to say that is 3 units in the positive x direction, depending on how the problem is stated. Let's see why the direction of each vector matters. What if, instead of adding the second vector as 2 to the west, it was 2 to the east? And notice, we don't have east or west on this, just showing that there's different ways to represent it, right? We've got plus x here and minus x. Plus x would be east, minus x would be west. So let's start again with the red vector, 5 units to the east, or in the positive x direction. Then we take the tail of the second vector, again, put it on the tip of the first one, but this way it's pointing to the right, to the east. So we have our 2 vectors. To find the resultant, we start back where the first vector was, at the origin, and we extend it out until we get to the arrowhead, or the tip of the second vector. This time our answer will be 7 units to the east. Right, this purple guy here is pointing to the east or to the right or in a positive x direction, and it's 7 units long. Okay, so that was adding vectors in just one direction, but life is never that simple. It's far more interesting. So now we're going to add the vectors on different axes. We'll have the same magnitudes as we did before, 5 and 2, but we'll put them in different directions. So we want to know the sum of a vector that is 5 units to the east plus another vector that is 2 units to the north. We start, as before, with the first vector. And the first vector is going to be 5 units to the east, or like we've said earlier, you could call that positive x, or we could call it to the right. There's probably other things you can call it, but those are the 3 that come to my mind. And now the second vector. This time it is not along the x-axis, it is going north. And what else could you call north? Let's see, we could call it plus y, we could call it up, but in this case we're working with north. So once again we take the tail of the second vector, put it on the tip of the first one, and this time it points in the upward direction 2 units. Right, there's 2 units right over there. The resultant vector, or the sum of the 2 vectors, once again starts where the first vector started, and it connects up to where the second vector ended.